Welcome to a weird fact about convergence. So recall in the absolute convergence theorem, we needed absolute convergence to guarantee that the sum from n equals 1 to infinity of a sub n was equal to the sum from n equals 1 to infinity of b sub n for b sub n simply being a rearrangement of a sub n. So the strange fact is that if we do not have absolute convergence, rearranging the terms of our series can change what it converges to and if it converges. So the fact is, if we do not have absolute convergence, so if we only have conditional convergence, then rearranging the terms can make a completely different or it can result in a completely different limit or sum. So for example, let's consider the alternating harmonic series. Which was the sum from n equals 1 to infinity of -1 to the n plus 1 times 1 over n. So this series converges conditionally but it does converge. And what it converges to is natural log of 2, right? So this series converges conditionally to the natural log of 2. So essentially what we have is 1 minus a half plus a third minus a fourth plus a fifth minus etc. goes to natural log of 2. Now we're going to rearrange to 1 odd term plus 2 even. Sorry, to 1 odd term followed by 2 even. So 1 odd term followed by 2 even. So again, the odd terms are my positives, the even terms are my negative terms. So this becomes 1 minus a half minus 1/4. Then we'll do plus the next odd term, so plus 1/3. Then we would have minus 1/6, minus 1/8, and then plus 1/5, etc. So if we group these, this is 1 minus a half, and then we have minus 1/4, and then plus 1/3 minus 1/6, followed by minus 1/8, and then we would go from there. 1 minus a half is 1/2, so you have 1/2 minus 1/4. Then we would have plus 1/3 minus 1/6. That's 1/6. And then we would have minus 1/8. Next up would be plus 1/10. And we would keep going. Now notice if I just factor out 1/2, this is 1/2 times 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 minus etc. And that should therefore be 1/2 times the natural log of 2. Or essentially, we have a rearrangement of this series, which was equal to 1/2 times itself, right? So this is just our alternating harmonic series popped up again. But it's now been multiplied by 1/2. So this is a very odd feature. We can make things converge to all sorts of different values just by rearranging our terms. So if we only have conditional convergence, we get this very odd feature. Absolute convergence, we can rearrange to as much as we like, and it will not change what the series converges to. So this was your sort of weird fact about conditional convergence.